of 1.
Okay.
Find the probability that a randomly selected x value is a given interval.
Okay.
All right, so
I'm sorry, give me the mean again.
The mean is 10.
And standard deviation is
1.
Okay.
And the first problem is between 8 and 12.
Okay. So, sorry, I had to erase our curve, but if we kind of need it, so I'm going to redraw it. There's the mean. And there is the mean minus 1 standard deviation. There's the mean minus 2 standard deviations. There's the mean plus 1 standard deviation. There's the mean plus 2 standard deviations. What percentage of the total curve is between 2 standard deviations less than the mean and 2 standard deviations above the mean?
Is that 99.4?
No, that's 3 standard deviations.
Oh, okay. So that would be 95.
Right.
Okay.
So the answer to their question, because this represents 8, 9, 10, 11, 12. And as long as we're talking about 8, that's 2 standard deviations away from 10, as is 12. So from 2 standard deviations below the mean to 2 standard deviations above the mean, 95% of the data is going to come in between those 2 points.
Okay, so deviation is just like the difference between each of the...
Not always. Standard deviation can be anything. In other words, depending on the shape of the curve, those numbers can be anything at all. You could have said x bar was 100 and sigma was 5. It depends on the data. There is a way you calculate sigma. It's a pretty complicated formula. It's a mathematical way you treat the data to figure out what sigma is. The mean is pretty easy. The mean is the same as the average. You know how to calculate averages. You take all the data and divide it by the number of data points. And that's your mean.
Okay.
Okay. Standard deviation has more to do with the spread. Let's say all your data points were, the mean was 100, and all your data points came in between 98 and 102. Okay? That'd be a really tight spread.
Right.
Now, I'll say another situation, the mean is 100, but all your data points come in from 80 to 120. Well, those are 2 completely different shaped normal distribution curves, and the only difference between them is the standard deviation.
Okay. So if the deviation is like 2 for this problem we just did, would it go 10 right to 8? Or like...
If the standard deviation was 2, and they still want the probability of that, then what they're asking for is the probability that you're 1 standard deviation away from 10. So, it's no longer 95%. What is it for 1 standard deviation?
Is it 68?
Yeah. Here's what it is. 1 standard deviation is 68% of the area under the curve, which translates to a 68% probability. 2 standard deviations is 95. 3 is 99.4. Now, do you know what the Higgs boson is? It's a fundamental particle in physics that was discovered about 4 years ago. All scientific discoveries are not announced officially until they pass the 5 sigma test. 5 sigma represents 99.4 4 more 9s, and then a 5. In other words, they discovered the Higgs boson a couple years before they announced it, but they were only at 3 sigma, so they weren't 100% certain. Although 99.4% certain is awfully certain, right?
Right.
But they didn't announce it. They kept collecting additional data, and when they had enough data that they could prove that it was within 5 sigma of the mean, that's when you make a scientific announcement, only when you have that degree of certainty.
Okay.
The difference between science and most other things is scientists do not accept a fact unless it is virtually certain, like 99.99995%.
Okay.
So this concept of sigma is extremely important in numerous areas, but particularly in determining scientific truth.
Okay.
You know, at what point would you declare something true? Some people might say, oh, when I get to 2 sigma. That's 95% certain. That's pretty certain.
Right.
So it's all convention. There's no physics that say that 5 sigma is the perfect number. It's just what we use by convention. Okay. Is we look for 5 sigma to declare something a fact.
Okay.
For example, let's say you found a person on the planet who had an IQ of 300. That is more than 5 sigma away from the mean IQ of everybody on the planet.
Okay.
So what might you be able to postulate from that information?
That they're basically the smartest person on the earth.
How about maybe they're an alien? Because there are no humans that have IQs that are more than 5 sigma away from the mean. So you might be able to postulate that, and that's pretty much what the Higgs boson was. They found a particle that didn't match anything else that we have ever discovered, didn't fit in any category except this rare category that, wow, this particle was predicted by math 50 years ago, and it was predicted by Peter Higgs, 100% based on math, not physics. And finally, after the Higgs or the Large Hadron was built, which is the biggest particle accelerator in the world, they were able to examine new particles, and they discovered the Higgs boson. And it's the particle that gives mass to all the rest of the particles in the universe. Only reason that lead is denser than aluminum is the Higgs boson gives lead more mass than it gives aluminum. All right, what other kind of statistic questions? This time I'll try to leave up the key parts. These are all pretty basic once you do a few of them, especially if you're not dealing with z-scores yet. You have to deal with z-scores when you're somewhere in between 1, 2, or 3 sigma. In other words, if you're trying to figure out what percentage of the curve is within 1.5 sigma, then it's a lot harder problem.
Okay. All right. So this next one, it's the same mean and deviation. So 10 for the mean and 1 for the deviation.
Okay.
And it says at most 9.
Okay. So, got to do these a little bit tricky. So let's draw a dotted line right there. What is that amount of the curve?
50%.
what is this amount that is 1 sigma less than the mean? What percentage of the curve is that?
Would that be, is that 0.34?
Yes. Well, no. Yes, it is 0.34. So it's 66%, right?
It says 68 in our book, so I don't know.
Okay. That's correct. I've been misstating it by calling it 65. 68 is the correct number. But what we're
Okay.
talking about here is if I go 1 sigma on either side of the mean, that's 68%, right? So this left half of that has to be 34%. So now I can say that 34% plus 50% lies to the right of 9.
Okay.
So what's the probability that it's at most 9?
16%.
Correct. Always 1 minus whatever else goes to the ends.
Okay, that's pretty easy.
Yeah. Actually, it is. Once you do a few of these, as long as they're giving you integer sigma amounts, it's very easy. Like I said, if they ask you what percent would be at most 10.5, a lot harder. Still doable, but a lot harder. And if they haven't taught you about z-scores, they're not going to give you any like that. You don't just take half of that. You can't do that. It doesn't work. Because you're talking about a curved line at the top. And what these things represent is the area under that curve. So if you were to look at the 10.5 mark right there, that would not be half of the area between 10.5 and 11.
Okay.
Okay? So that's why it's much harder, and it involves these things called z-scores. But no point in even bringing that up if they haven't given you any problems like that.
Right.
Yeah, I should have remembered that 68% because the one I always remember is the 34%, which has to be half. So, what else?
So there's a new set of problems. It says use the fact that approximately 2% of people are colorblind and consider a class of 460 students.
Okay.
Okay, so the first question is what is the probability that 15 or fewer students are colorblind?
How many students would you expect to be colorblind?
2% out of 460.
So what does that translate to?
Let's see.
What's 1% of 460? You don't really need a calculator here.
That would be
1%, which you can do in your head, and then multiply it by 2. Okay?
okay.
You would expect that every 9 students, you're going to find a colorblind student. So it's 1 out of 9.2. Now, 15. Is this still on topics concerning normal distribution? I kind of doubt it because they're not giving us any sigma.
Yeah, I don't think so.
So how do we do this problem? You're not taking a statistics course, right? You're just getting the statistics from your pre-calc?
Algebra 2 trig.
Just Algebra 2 trig. Okay.
Yeah.
don't generally give you very tough statistics problems in Algebra 2 trig. You don't really get tough until you actually take statistics and probability. Trying to think how we're going to do this. I think it does kind of depend on the shape of the normal distribution. Don't you think it would have to? In other words, here's what I'm talking about. And yet they don't give you enough information to base it on that. Let's say, oops, hold on. Let's say it, okay. So what that means is the mean would be 9.2. Problem is that 15 students might be 3 sigma away, might be 5 sigma. You know what I'm saying? In other words, if we presume that this is 2% of one school, right, with 460 students?
Yeah.
So if we were trying to get an estimate on what the national rate was, and you did this study at a number of different schools that all had 460 students, you're going to find in some cases the average is going to be 9.2, but you're going to find some schools where there's 15 colorblind students. And you're going to find other schools where there's only 3. So it definitely is going to follow a normal distribution, as a lot of things do. Certainly things like this, or heights, or weights, or whatever. And the probability of finding 15 students given this information has to depend on the shape of that curve. In other words, what if that curve, instead of shaped like I've drawn it, is shaped more like this? Much flatter. Well, then clearly 15 is going to be a different probability than the red curve, because it's going to be a different number of standard deviations away from the mean.
Yeah.
So they must be figuring this a different way. They didn't give us any information about standard deviation at all.
I could check in the back.
Do you know, do they give you the answers on these?
There's an answer.
By all means, go ahead and check, and let's figure out how they do this, because I'm not real sure, to be honest. Statistics isn't really my forte. I know a little bit about it, but I'm not what you would call a statistics expert. I got a feeling they're just doing it some other way.
All right, so the problem I give you is an even problem, and they only have answers for odd problems. But there's an odd problem that's really similar.
Okay, let's look at that.
Okay. So it's still a 2% probability of colorblind in 460 students. But it says, what is the probability that 12 or more students are colorblind?
Okay, how does it do this one?
It just gives me the answer, so.
Oh, that's not helpful.
Yeah.
If I can find the answer. I do have an AP statistics book, but I'd have to do some research, and we only have 5 minutes.
Right.
So here's what I'm going to ask you to do. If you're still doing statistics by next Monday, try to send me a picture of the problems before the session.
Okay.
At least an hour before the session. That way it gives me enough time to do a little research. I'm sure I wouldn't have to look hard to find an example just like this. And it's probably a real simple formula. I just don't know what it is. Especially if they don't give you standard deviation.
Yeah.
You know that there are some problems in my statistics book where they don't give you standard deviation and you can still kind of answer it, but they're really the tough ones. You wouldn't be getting those. At this point, you're only going to be getting ones that are relatively easy. I don't think there's any way you can assume or figure out a standard deviation. Yet, in my mind, it seems like it's an absolute necessity to know what it is. Because otherwise, you don't know if you're looking at a red curve or a blue curve. And you're going to get different answers depending on which curve you're looking at. What was their answer for 12 or more? That has to be a relatively small number. Like,
I think it was. It was 16%.
Okay, yeah. Because if the mean is 9.2, then you have to get a relatively far ways away from the mean. And that certainly isn't going to be. In other words, if it's represented by a normal distribution curve, then half the schools that would be tested would be below 9.2, and half would be above 9.2.
Yeah.
If that's even what they're talking about. Because I didn't hear in the problem you gave me that they were going to be testing multiple schools, all with 460 students. And the average colorblind is 2%. But each individual school might have a different rate. You know what I'm saying?
Yeah.
In other words, this is the same as 2% right here.
Okay.
9.2 students would be the average, and that equates to 2%. But if you were going to draw it up like this, like I said, I don't know how they're going to do that.
Right.
I hate to leave you like that, but there are going to be some subjects where I need 15 or 20 minutes to refresh my knowledge of them before I'm going to be able to help you in real time. And I'm just surprised that it's this level of statistics. I should know this. I don't know how to do it, though. So you have any other type questions? Well, it's actually 6:30. Why don't we go ahead and call it a session?
All right.
And I'll take a look at this problem and see if I can see an example of it. The problem is by next Monday, you're going to be way beyond this. Right?
I don't even think we went over this in class, so I don't know if he's going to test it.
Okay. If you're on some exotic stuff, and normally you're not. Normally you're on stuff that I know right away.
Right.
But some of the stuff can, especially at this time of year, they're doing the final stuff before they stop adding new material and start reviewing for your finals, right?
Right.
You're close to that period. A lot of my students, that was spring break. In Calc BC, they stopped adding new material at spring break. And everything is review after that. Might not be quite that way for you yet. Yeah, that's mainly because they're preparing them for the AP exam.
Oh, okay.
Whereas you don't have an AP exam for your course.
Right.
But nonetheless, they will stop adding new material and just review after a while. And I'm fine with that. Review, I'm great on. But sometimes some of the newer material they add right at the last bit of the semester is stuff that just is beyond Common Core. This is not Common Core, actually. They will never test you on this in the SAT test or the ACT test.
That's good.
Well, yeah, although at this level, as long as you just have to remember 68%, 95%, and 99.4%, it's pretty standard.
Oh, okay. I thought you were talking about the one we were trying to figure out.
Well, yeah, this is not so standard. This is never going to be on your ATP test either, or your SAT test. No,
Right.
This is a lot harder, the one 12 or more, or even 15 students. There must be a way of estimating standard deviation from that information. I just don't know what it is. Because it seems to me you need to know standard deviation to answer the question.
Yeah.
But anyway, Jake, I will talk to you next Monday.
All right, sounds good. Thank you.
You're welcome. Bye-bye.
Bye.